All right, for this lab, I want to talk about creating your own function to do a job, okay? And so what usually happens is usually you have two, I don't know, I would say formulas, and they might either be given to you, so maybe they're both given to you, or I know this is kind of a bad, but there you go. There's your brainstem. All right. So it should either come from your brain, something you know, or it's given to you. So it could be two given, two from your brain, one of each somehow. But you combine them, and usually we want a function of x. Sometimes it could be a function of the radius or function of something else. But what's going to happen is you have two formulas and you combine them into a function that typically only has x's in it. It could be a function of time. Then that means that when you combine your two formulas, you only have time in here. All right. And so some of the formulas that might be in your brain is that area of a circle is pi r squared. Circumference is easy to remember. Clowns get pied in the face, like in a circus, clowns get pied. So pi times diameter goes with circumference, pi r squared area. And that makes sense because you need square feet, square meters, or whatever with area. Maybe the distance formula, so change in x squared, change in y squared. Maybe it is Pythagorean theorem, so a squared plus b squared equals c squared. So it's just some formula, perimeter of a rectangle, 2 width plus 2 length, or area of a rectangle, width times length, or maybe area of a triangle, half base times height. So those are just kind of formulas that you should know just having been a user of mathematics for a while, okay? And then what happens is you usually, maybe I give you another one, okay? And you combine them to create this function, okay? Or maybe you combine two of these to create a function. All right, so let's look at, I have this sheet. We'll do some of the, I don't know, simpler ones, I hope, on this. And then just to kind of get an idea. All right, so let's look at 13. All right, and this is from another textbook I sometimes teach out of. A wire of a length of x is bent into a circle. Okay, so if you think of this, x is that distance around, which again, we call that circumference, right? So the circumference is actually x, okay? Now, again, what do I know from my memory? Well, I know pi d, clowns get pied in the face. So I know that x is going to equal pi times the diameter. All right, so circumference is x. Okay, but these are formulas. Notice they're not functions. Express the area of a circle as a function of x. Okay, so what else do I know? Well, I know that area of a circle is pi r squared. Again, totally different formulas. So I have two formulas. I want to somehow combine these to create a function. Okay, now what do they want? They want a function of x. Okay, so if I look at my paper, all right, I'm like, okay, I want to write area as a function of x. So area is my main formula. So area equals pi r squared. But right now it's a formula. I want to switch over to a function. So I want to kind of cross a line and say a of x equals pi. But notice if it's a function of x, it can't have r in it. It has to have the variable x in it. And you're like, but I don't have an r down here. Okay, so this is our main formula. We're trying to sub this guy into that, but right now we can't. But notice I know that diameter is 2 radius, okay, or 2 radii, I should say. So I know that x is equal to 2 pi r, okay? So if I divide, I can figure out what r is. So I am going to divide by 2 pi. So the 2 cancels and the pi cancels. So now I know what r is. Okay, so r is, I'm going to replace it. It's what? X over 2 pi. And then I have that squared. So I get pi, square the top, x squared, square the 2 is 4, and square the pi. And notice one of the pi's can cancel, so I'll just cancel that. So my function a of x is equal to x squared over 4 pi. So what that means is if I know how long my wire is, x, I can just sub it into this formula and it will spit out the area, okay? All right, so again, I took two formulas I knew and I mushed them together to create a function of x. All right, let's look at 14 here. All right, so 14, a wire is now, okay, so now we're bending it into the shape of a square. All right, so let's take our wire, we're gonna bend it, okay, in the shape of a square. So if it's x long, this would be a fourth of x, a fourth of x, a fourth of x, a fourth of x, okay, because that would all add up to x. And we know it's a square, so we know everything is equal. All right, what does the first part? Perimeter. Okay, we know perimeter is when you add up all the side lengths. So I know the perimeter is equal to x. All right, the area of a square. Okay, so an area of a square or a rectangle is length times width, okay, or base times height. So right now, do you see how these are both formulas? And I have two variables here. So to cross a line to a function, I can't have length and width. I have to have, you know, all x's. Well, length and width are the same here. So a fourth x times a fourth x, which is 1/16 x times x is x squared. And that is a function. So again, I only need to know x to get the area, okay? And again, x isn't a side length, x is a perimeter. So if you tell me the perimeter, I can tell you the area, okay? All right, so let's actually try that. What if the perimeter is, say, oh, I don't know, let's say the perimeter is 4, okay? So if the perimeter is 4, we know it would be what? 1, 1, 1, 1 to have that happen. All right, so let's sub it in. 1/16 times 4 squared. 4 squared is 16. 16 divided by 16. See how it spits out the area. So by just knowing the perimeter, okay, if the perimeter is 4, I know the area is 1, and all I have to know is the perimeter. All right, let's look at one more, and then I'll show you one on DESMOS here. All right, this one. All right, so we have this inside here. All right, so again, what do I know? Well, some of it might be memory, but some of it is from this picture as well. So if this is the radius, notice if I bring it down, this would be radius and radius. And if I bring it straight up, that would also be radius. So part of this is visual here. Semicircle, what do we want to find? Okay, we have the figure. Express area. Okay, so we want to find a function for area and a function for perimeter, but this time it's a function of r. All right, well, because I could look at the picture, that's going to help me write my function. All right, so I'll just do this over here. A of r. Okay, how do I find area? Well, area is length times width, correct? So that's my formula that I normally know, but this is not a function. But notice I know the length and the width, okay? And this could be, again, length and width is area. So if I want to do this, r, and then r plus r is 2r. So 2r squared is going to be my area function, okay? What about perimeter? Well, perimeter is usually what? 2 width plus 2 length, or you add up all the sides, or maybe 2x plus 2y. Well, again, because I have this picture, I can kind of see it. Perimeter of r would be add up all 4 sides. So I have 2r, and 2r is 4r, 5, 6r. And again, if I know the radius, okay, so if I know the radius of this is 10, then I know the perimeter is 6, and I know 10 squared, 100 times 2 is 200. So this would be 200 square units, and this would be, what I say, 60 normal units, okay? All right, I'm going to pause for a second, and then I'm going to jump on to DESMOS for a second. Okay, so say I give you a function. This is given. Okay, it's a problem. Notice it's negative. It's been reflected. And I want to find the biggest rectangle or square that I can make in this shape right here, just in quadrant 1, that gives me the maximum area. All right, so think about what you know. I'm giving you this function, and I also know that area is length times width. So I'm going to call this x, this distance x. And so then I can write my function. So I'm going to pause a second, go back to my sheet here. All right, so from memory, you know area is length times width, or x times y in this case. And I'm giving you that the function, or y equals this. So notice you can just sub this in for y, and it crosses the line into a function. So area of x, or area function of x, is x times, and then I'm going to sub that in, and of course my pen's dying. Okay, now I want to find the maximum area. So notice this function, you sub in your x distance. It doesn't give you y back, it gives you the area back, and then it will have to do a little math to figure out what the length and width are. Okay, the length or the width is given, but figure out the length. Okay, so I'm going to pause and I'm going to type this into DESMOS. Now notice this is a new function. We use the old function or the old equation to create a new function. So I'm going to graph this one and we're going to try to find the maximum area. Okay, so we look at our graph, it definitely changed, and we're only in quadrant 1. So if you think about domain and range, do you see how if this is a positive 2, I get an area of 0, okay? So my domain is 0 not included, all the way to 2 not included, okay? So we're only in here. Now, what is our max value up here? All right, so we're trying to figure out the maximum value, right? And so if I click on there, I get the maximum value. Now, what does that tell me? That this is my x distance. This is not my y value. This is not that. This is my area. It gives me the max area of this. So if I want to figure out my length and width, I could do a couple things. I mean, it's a rectangle, right? So I could take this divided by this. Okay, I mean, that's a possibility to find that. The other thing I could do is sub this into my original to see where it's at. Okay, so I'm going to pause for a second to do those to kind of show you how I can get the length. All right, so again, remember this is a new function. This is our area function. I'm going to get rid of this for a second here. Okay, so how do I figure out the length and width? Well, I know the width. I know the area, so if I divide those, because it's just a rectangle, I can get the length and width of that guy. So it should be 1.155 by 2666 for the y value. Or remember, I could go back to the original function and substitute in my x value, because this has to be a point on that parabola. So if this is my input, I can get my output. All right, now I'm going to go back to the original graph, not the graph of the area. I'm going to go to the original graph of just the original parabola to show you that this literally is on it. All right, so I'm going to let me bring this guy back. And I'm going to delete this. So we just have our original function. This is not the area function. And so the point that we ended up with was what? 1.155, comma, and then we think the y value is what? 2.666, and I can plot it. So right there, that rectangle there. So if I take a screen, oh boy, Julie. Sorry, just kind of have to minimize. Let me pause a second. Okay, so I grab my snipping tool here. So if what it's saying is if I drew in this rectangle, which again, I'm not very good, in first quadrant, all right, the width is this. This is your x value. This is your y value. That's what, is on the parabola. But the second function is what telling me the area. So if you take length times width, what is the maximum area you can get? And so if I put an X in here, that is the area. Now notice you're like, but that point's not on it. That's because that's not, this point is input is your width, output is your area, okay? And then if you have a TI 84 plus, to get this, you can do second calculate and you can find the local max in that area. But again, what is your domain and range of this function? None of this makes sense. So domain is not including 0. You can't have a width of 0. All the way to 2, you can't have a width of 2 because you can't get an area of 0. So 0 to 2 with parentheses. Okay, and then as far as your range goes, 0 is not included. You can't have an area of 0. And then your maximum is that. So you could have a y value equal, so bracket 3.079. I'll pause and write that quick. Okay, so again, domain 0 to 2, because that's your width, can't be 0, can't be 2, anything in between is okay. And the range can't be 0 for area, but the max area can't equal that, so you get brackets. All right, I'm going to have you guys try one and kind of talk about it for this lab. Oh, it's not cutting me off. I don't know why. All right.